Hello everyone and welcome back to Tech with Jaja. Today we're diving into one of the most fundamental topics in programming, and today we're going to do something around C++. In this video, we're going to talk about the basic types of data in C++. To help you understand their importance, let me paint a picture using something we all learned about in biology, the cell. In biology, cells are the building blocks of life. They are the simplest unit or the smallest unit, yet they come together to form all the complex organisms we see, like the humans, animals, and plants. In programming, these basic or primitive types of data are just like those cells. They are the simplest and most basic units of data. Think of these types of data as the DNA in programming. Just like cells are the basic units of life in biology, these primitive types of data are the basic units of information in programming. They define what type of data we can store and how much memory it will take to store those data and the operations we can perform on the data. Think about it. The music that you listen to, they are just a collection of numbers and characters in your computer memory. These numbers and characters are primitive types of data in programming. Your videos too, they are just massive amounts of processed numerical data. How about your applications? At the very core of it, they are nothing more than primitive types of data working together in harmony. C++ provides us with these fundamental building blocks, and we are going to be discussing about them in this video. And by understanding them, you gain the power to store, manipulate, and transform data, just like cells are transformed to create living organisms. In today's video, we will explore what primitive types of data are in C++, the categories they fall into, how they act as the foundation for everything else in programming. By the end of this video, you will see how these programming cells fit in together to create incredible complex applications. So if you are ready to uncover the DNA of coding, grab your notebook and PC and get set for some learning. Here is where your coding journey starts. Don't forget to subscribe to this channel if you haven't. Now let's dive right in, shall we? Let's go. So before we dive into the specifics of the primitive types of data in C++, let's take a moment to understand what the types of data are and why they are also important. In simple terms, data is any piece of information that a program can use. It could be a person's name, their age, the price of an item, or even a true or false condition. For example, your name is a piece of data. My name, Jaja, is also a piece of data, right? Your age is another piece of data also. Whether it is raining outside or not is also data. But here's the thing, not all data are the same. Some data are numeric, like your age, some are like text, like your name, and some are logical also, like whether it is raining or not. So to make sense of this information, we group them into types. For instance, numbers like 5 or 3.14 are grouped under the numeric types, that is, the data we can use for counting or calculations. Letters like A, B, C, or Z fall under the category of characters. True or false statements are categorized as yes or no replies, also called the Boolean types. By categorizing data into types, we can decide how to store it, how much memory it will take, and what operations we can perform on the data. In C++, these basic categories are called the primitive types of data. They are the simplest and most fundamental types of data, and they form the foundation for everything else in programming. In C++, the numbers are split into two categories, whole numbers and fractional numbers. The whole numbers are numbers that does not have decimal parts, like numbers we use for counting or storing ages. Yes, they can be positive, negative, or even zero. But the rule is that they must not have a decimal part. The general name that we call them are integers. So for example, 5 is an integer, negative 10 is also an integer, 0 is also an integer. In C++, integers are represented by the int keyword, which is used to store whole numbers without decimal points. The int type of data can represent both positive and negative numbers as well as 0. So from the example on the screen, we are initializing three integer variables, name, temperature, and count. Age is set to 25. representing a person's age. Temperature is set to -10, representing a negative temperature, and count is set to 0, typically used to represent a counter or a starting value. Integers are generally used for counting, indexing, or storing whole numbers. They usually take up to 4 bytes of memory in most systems, but this can vary depending on your computer's architecture. The second category are numbers that have decimal parts, like the numbers that we use for measurements and calibrations. Just like integers, these numbers can also be positive, negative, or even 0, but the rule is that they must have some fractional parts. Now, C++ is a programming language that is known to manage memory very well. So when storing numbers like this, you can ask yourself, are you storing a number that is precise or a number that is very precise? So if you want to work with a number that is precise and with a very few numbers of decimal points, then you will store it in a category we call floats. Floating point numbers, or floats for short, are numbers with decimal points. They are used for measurements, calculations, and anything that requires precision. For example, 3.14 is a floating point number. Negative 0.001 is also a floating point number. 2.0 is also a floating point number. So if you want to store something that is very precise, that is very accurate and have more numbers after the decimal, then you store it in a double floating point type, also called double for short. So, and you can see the examples I gave to you on the screen. So as earlier said, a float is suitable when you don't need extreme precision. It uses less memory, while the double uses more memory. Floating point numbers have a precision of about 6 decimal digits and takes up about 4 bytes of memory, while the double floating point numbers, or double, have a precision of about 15 to 16 decimal digits and takes up about 8 bytes of memory. The next category are the single characters. This is used to represent the alphabets, letters, or symbols that we use every day to record or display text. For example, a student's grade can be A, B, C, or D. Someone's sex can be M for male or F for female. In C++, characters are put inside of single quotation marks. It is very important that you know this. That is, whatever is enclosed inside of single quotes, even though it is a number, C++ does not see it as a number but as a character. In C++, characters are represented by the char keyword. A variable of type char holds a single character, such as A, B, or 7. Behind the scenes, characters are stored as numeric values according to the ASCII encoding system, where each character is assigned a specific numeric values. Characters take up 1 byte of memory in most systems. While the regular character type is used for storing single byte characters like English letters or numbers, it can handle characters from languages that require more complex symbols, such as the Chinese, Arabic, or even emojis. There is a type of category in C++ that handles this, which is the wide characters. The wide character type is used to store characters that does not fit into the traditional character type that we discussed earlier. Wide characters are also enclosed in single quotation marks, just like the other characters. Just that we have to put a prefix of capital L before the quotation mark. These have a special meaning in the compiler to tell it that we are working with wide characters. C++ also has a special keyword for the wide characters, which is char_t, which is an abbreviated way of saying wide character type of data. Just like you would guess, computer uses more memory to store wide characters than it would for traditional characters. In most systems, the wide characters take up to 2 bytes of memory. In programming, one of the most powerful features of the computer is the ability to make decisions. The Boolean type in C++ is used to represent truth values, that is either true or false, which are fundamental in evaluating conditions, making decisions, and controlling the flow of a program. Boolean values are most commonly used in conditional statements like if statements and loops like while or for loops, where program executes certain blocks of code based on whether a condition is true or false. In C++, the bool keyword is used to declare a Boolean variable. A Boolean variable can only have one of 2 values, either true which indicates that the condition is satisfied or the statement is correct, or false, which indicates that the condition is not satisfied or that the statement is incorrect. The Boolean type of data typically takes up 1 byte of memory in most systems. So in C++, the void type of data is a special type of data that represents the absence of any type. It doesn't hold a value, but is very useful in certain situations, like when defining functions or pointers that do not need to return or store any specific type of data. When you define a function in C++ that doesn't return any value, you use the void as the return type. This tells the compiler that the function doesn't return anything when it completes. In these cases, the function is typically used to perform an action like printing to the screen or modifying variables without giving any result back. In the example on the screen, the function printMessage doesn't return anything. It simply prints a message to the screen. The return type is void because there is no value that the function needs to send back to the caller. By the way, functions and pointers are some concepts that we'll talk about in later videos in this series. Void itself does not occupy memory because it represents nothing. However, void pointers typically occupy the same amount of memory as any other pointers in the system, which is about 4 to 8 bytes depending on the architecture of the system. Here is a recap of the primitive types of data we've discussed so far. The integer, which is used to store numbers both positive and negative as well as 0. No decimal point is allowed. The float, which is used to store numbers with decimal points, suitable for numbers that doesn't require high precision. The double, which is similar to float but with more precision and accuracy. The Boolean values, which are used to store true or false values, commonly used for decision making and logical operations. The characters, which are used to store single characters like a letter or a symbol. The wide characters, which are used to store characters like emojis or Chinese alphabets. The void type, which represents the absence of a value, primarily used for functions and pointers. Speaking of memory, I have mentioned the default memory sizes that we use to store these primitive types of data, and this is particular to your operating system and computer architecture. However, these memory sizes can vary depending on your system architecture, like I just said before. You can also have access to modify these sizes of these types of data with the use of modifiers. Modifiers allow us to change the size and range of the types of data you want to store based on your specification. We will dive deeper into these modifiers and memory management in C++ in our upcoming videos, where we will explore how to customize types of data, work with different memory sizes, and optimize our programs for better performance. So here is what we'll call it a day on the types of data. If you found this video helpful, please give it a thumbs up, subscribe to the channel for more programming tips, and share it with your friends too. Also, don't forget to turn on the notification bell so you never miss out on any upload. Thank you for watching, and I'll see you in the next video. Happy coding!